In question number 63, we have a capacitor of 10 microfarad. It's connected to a battery of 2 volt, and they say that it takes 60 milliseconds for the battery to charge to become 12.6 microcoulomb. We need to find the resistance of the circuit. I'll suggest that you see my video on charging a capacitor through a resistor on this channel, and also check for derivation of the formula. So when we have this capacitor and a resistance R and this battery voltage 2, initially this capacitor has no charge. As soon as we connect the battery, the charge starts flowing through this resistor and starts accumulating on this capacitor. Initial current is fast, but as there is a accumulation of voltage on this capacitor, there is a smaller voltage available on this resistor, and the voltage across this resistor reduces, so the rate of the flow of this charge reduces. So the battery voltage on this, or the charge on this, keeps rising till this battery voltage on this becomes equal to this. And this is how the curve of QT is the charge on this capacitor at time t, is rising with time. The formula for this is Q is equal to Q0 1 minus T to the power minus T divided by RC. Sometimes you may confuse that the formula is Q into T to the power minus T by RC. So once you write this formula, you can verify that what is going on at T is equal to 0 and T is equal to infinity, to verify that the formula is correct. At T is equal to 0, this becomes e to the power minus 0 or e to the power 0, and e to the power 0 is 0, 1 minus 0 is 0. So this Q is 0, which is correct as per our graph, general shape of the graph. When e is equal to infinity, this becomes 1 upon, this whole thing is actually 1 upon e to the power t to the power RC. And when t is equal to infinity, this is 1 upon e to the power infinity, and 1 upon infinity is 0. So this Q becomes equal to 0, which is in accordance with what this graph says. The final value of this charge is something Q0, and Q0 is the final value of the charge. It is determined by Q is equal to CV. Q is equal to CV, where C is the capacitance and V is the final voltage with which it is connected. So with this formula in place, we need to find out if this final charge at certain time t, this charge becomes 12.6 to 10 to the power minus 6 coulomb. What is the value of what is the value of R such that it happens at this time? Now Q0 is CV, we know. C is 10 microfarad and V is 2 volt. So this is QCV is here. And then 1 minus e to the power t is given as 50 milliseconds, so it's 50 into 10 to the power minus 3. R is need to be find out, and capacitance is 10 microfarad. 10 to the power minus 6, 10 to the power minus 3 becomes 10 to the power plus 3, and this plus 3 can also be simplified. This 0 cancels here. 5 into 10 to the power 3 is e to the power minus 5000, divided by, of course, R. And then this 10 to the power minus 6, 10 to the power minus 6 cancel. 12.6 divided by 20. That becomes 126 by 200. 100 cancels. 1.26. This becomes 0.64. So we take e to the power minus 500 by R on the left hand side, and this whole terms on the right hand side, those become 1 minus, this becomes 0.64 or 0.36. E to the power minus 5000 divided by R is 0.36. Now at this point we can take the natural logarithm of this. If I take the natural logarithm on both sides, this becomes minus 5000 by R. This is log E 0.36. And here couple of things we need to remember for the examination, and one of the things is log natural to the base e to the power minus 1 is equal to 0.36, and the reason for this is E is 2.37. So 1 upon E is about 0.36. 1 upon E is nothing but e to the power minus 1. So if we take the logarithm of e to the power minus 1, this is nothing but 0.36. If there are few, you don't need to remember all of this combination of logarithm, whole logarithmic scale, but you should know the key. For example, natural logarithm of 2.71 will be equal to 1 because log 2.71 is E, the value of E. So this becomes minus 1 cancel, R is equal to 5k.